Sweet. Let me get back to the quiz. Okay. Question 3. The symbol of true population proportion is which of the following? So that one just P.
Yep, that's what I put.
Awesome. What's the one with the squiggly? What's that called?
I'm not sure.
I don't know if I've seen that one. Okay. Okay, question 4. The requirements for constructing a confidence interval are satisfied. True or false? What do you think?
So I said it was true.
Okay.
Hold on a sec.
Yep.
Okay, let's see. I look back. Oh, I guess I didn't do any calculations on this. I think you're probably supposed to.
Okay.
Because 11 and 12 are similar questions. So,
Gotcha.
okay, let me see. Oh, okay, I see what we got to do. We got to do the n p hat is greater than or equal to 10. And n times 1 minus p is greater than or equal to 10, I think.
Okay. So n times p hat. Okay, gotcha. So n times p hat is 10, correct? So that would satisfy the first one.
Yeah.
Then the next one, 1 minus p hat is 0.9, right?
Yeah, and then times it by 100.
100, which is 90,
That's
right?
Yep, that's greater than 10.
Right, 0.9, yeah. So that, yeah, so true then, right?
Yeah.
Sweet. Okay.
And for a hypothesis test, we do the same thing. We just use p instead of p hat.
Okay. So n times p is is 25, so that passes.
Mm-hmm.
And 1 minus 0.25 is 0.75 times 100 is 75.
All right.
Passes as well, right?
Correct.
It will be true. Cool.
All right. So then, study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these 45 the defendants were found guilty. Find p hat the point estimate of the proportion of first-degree murder defendants who are found guilty in this state. So that'd just be 45 divided by 60, wouldn't it?
So of these 45, I believe so. Let me.
You find p hat by just x divided by n.
X divided by. Okay. Yep. So 45 divided by 60. 0.75.
That's what I got.
Okay.
Then 7, 8, and 9, we're finding the margin of error, and then the upper bound and the lower bound.
Okay. So, margin of error. Okay. What is the formula for margin of error?
It is M equals z-score times the square root of p minus 1 times 1 minus p divided by n. So,
Do you know where that's at in the textbook?
yeah, it is.
Oh, I think I just found it. Okay, so z-score divided by, oh wait, nope.
It's 3. It's on section 3, sample size calculations.
Scroll up. Okay, oh, right there, z-score times, what is that one, the p square root, that relates to what number?
Oh, the p?
Isn't the square root that part of the equation part of something else?
Yeah, you also use that for the upper bound and lower bound.
Oh, okay. Gotcha.
You do the z-score plus and minus that part of the equation.
Oh, okay. So, what would be our p-value? Do we?
It's a good question.
Oh, or do we use the above information? Yeah, we do. Sorry. So, did you say you already did this one?
Yeah, but I just realized I just used p hat instead of p without thinking about it.
Oh, okay. Okay. We find the p-value by p. I forget what's the relationship between p-value and p. I mean p hat and p.
Yeah. Let me take a look back at last chapter. I'm just gonna look really quick.
Okay. I wonder if in 2.2 if it answers our question. Point estimate for p is p hat.
Oh, is that what it says?
Yeah. So you might be good on your answer then.
Okay.
I do need the probability app. So 95%. That's what we're.
Yeah.
Oh shoot! And for this, do we? Forget. Do we shade the outsides or the insides of the normal probability applet?
Oh. What are you using the probability applet for?
Define z-score.
Oh, the z-score is 1.96.
Oh, did they give that to us?
Yeah, because it's a 95% confidence interval.
Oh, okay. Nice. Okay, so then that for this one. Change this one. And then what's our N?
N is
60.
yeah. Yeah, N is 60.
One 1.96, right?
You got the margin of error of 1.96.
Oh, sorry. No, what's the?
Oh,
That's the z-score.
Yeah, 1.96.
I got 0.1095. Seems really. That's what I got.
0.1095.
Uh-huh.
Yeah, I think I rounded my. Let me see. Yeah, so how would you round that?
Point 0.11.
Yeah, that's what I rounded it to, was 0.110.
You round the 5, rounds the 9.
Yeah.
Yeah, so point 0.110.
That's what I got.
Cool. Okay, input the lower bound. So do we just take that number?
Yeah, so you take the number you got for the square root of 0.75 times 1 minus 0.75 divided by 60
Uh-huh.
times 1.96. And then you just subtract that number from 0.75 and add it to 0.75.
Okay. Okay, I got 0.640.
For the lower bound.
Yep.
Yep, that's what I got.
Okay. And then for the upper.
Would it be, oh, you got 0.640?
Yeah.
Okay. Would it be 0.641? I got 0.6405, but
Yeah, I got 0.6404. I
oh,
think it's
I didn't use the rounded version, so that's probably why.
okay. Okay, and then I got 0.85956.
I'm gonna double check it.
0.86.
0.86.
Yeah.
That's what I got.
So if you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? I'd say decrease.
That's what I said.
Cool. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 1/2. What is the smallest N can be and both requirements still be met? Okay, so this one for the N times 20 times 1/2 would be greater than or equal to 10. And for the other one, where's that? Okay, this one. 0.75. Okay. 10 divided by 0.75. Have to be 13.33.
Yeah, how did you explain to me how you get those answers?
So, the confidence interval is the same as a hypothesis test, correct?
Yeah, I believe so.
Except you're using P instead of P hat. So the first equation is the N times P,
Mm-hmm.
and it has to be greater than or equal to 10.
Okay.
For that one, because it gave us P is 1/2,
Mm-hmm.
for N times P, what did I do? I divided N divided by P by P, which is 0.5. So you do it to one side, you have to do it to the other side. So 10 divided by 0.5 is equal to 20.
Mm-hmm.
That makes sense. And then we just do the same thing for the next one, where you do 1 minus, oh, I did my math wrong. You do 1 minus 0.5, you get 0.5. Then you do 10 divided by 0.5, and you get 20. So actually, I think it's 20, not 13.3, but 20 would be the smallest.
20 would be the smallest.
Yeah.
Okay.
Does that make sense?
Yeah, it does.
Okay.
So now it's 1/10. So you just do the same thing, right?
Yep.
1/10. So it'd be 10 divided by 0.1.
Yep.
So you get 100.
Correct.
All right. And then you do 1 minus 0.1.
Uh-huh.
That's 0.9, right?
Yep.
And then do 10 divided by 0.9.
Yep.
11.11.
Yep.
That's your answer, right? 11.11.
So it's actually 100 because 11.11 doesn't satisfy the
Oh,
NTP.
tricky.
Yeah. But the 100 would satisfy both of them.
Because that's greater than
Yep.
10. Okay.
Yeah.
Sweet.
Okay. Sweet. Use the following information for the next 6 questions. For the water quality study and the reading, about 60% of the macroinvertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using significance levels of 0.05 with the following hypothesis. They collect new data, and this time n equals 80 and x equals 38. Indicate this time, and indicate good health. Conditions for conducting hypothesis tests are satisfied. True or false? So we get P from dividing.
38 divided by 80.
Okay.
Yep, 0.475.
Yep. That's our P value, correct?
Well, I guess that's technically P hat, but
Yeah.
yeah.
Okay.
That's question 14.
Oh, is it?
Yeah.
Nice. 475. I think we can say it. Conditions are good, are satisfied.
Yeah.
It's over 30 for our number of people being conducted.
Yeah. Okay. And P hat is 0.475.
Yep. Test statistic. How do you find that? Seems like that was ages ago.
Yeah, it does.
Oh, you're not in SPSF. I'm gonna say it's BF and SPSF.
Yeah. We have it one for Excel, but they didn't give us data points.
Oh, isn't it? Yeah, sorry, I did it when I was SPSF.
Yeah. Oh, where? Oh, excuse me. Is it categorical data or categorical? Oh, wait, this one.
Okay, so I think, yeah, it is categorical data analysis. So I'm just plugging things in. N is the same as the T statistic, right?
Which one?
N.
N is the number of people
Oh, yeah.
interviewed, or
What's the T statistic?
T statistic.
That's a 1 proportion sample test, right? Yeah.
Yeah. Excuse me.
I know the P value.
Yeah. Hey, did
0.011.
the P value is?
Yeah.
Okay. Hey, did you open up a Excel form or Excel page on the test, and was it corrupted for you?
You say corrupted?
Yeah, the file from the test.
Oh, yeah. I think one of them, if I remember right, one of them seemed weird.
Man, ever since it popped up, this file has been corrupted. My Excel has been horrible.
Really?
Yeah.
Oh, dang.
So.
Oh, it's a bad file, like virus?
Yeah, so like it had something connected to it.
Oh, dang. That's not good.
No, like I can't shut. Might be my computer. I don't know, but it won't let me close any Excel files or open new ones.
Dang.
It's like, come on.
Yeah, that's not good.
From the school, it's supposed to be protected.
Yeah.
Okay. So what'd you find?
So, why can't I remember how to find the test statistic?
Yeah.
But the p-value is 0.011.
0.011. Okay.
And what else is it asking for?
What is the
Decision for this test?
Reject or fail to reject? Both our p-hat and our p-value are below what they expected.
Yeah.
So reject.
I think so.
Okay.
Which of the following best summarizes the conclusion of this test?
I'd say the last one.
Yeah. Then
Has decreased.
yeah. Test statistic. Man, how come I cannot remember that?
Let me Google it real quick. Test statistic. Okay. Sure. Yeah.
Just like this.
Maybe shaving.
Yeah. Okay.
Nice about.
Want that stuff?
Yeah. Okay. So is there a spot for what are we doing T statistic or T? Is there a spot for a T test?
Not on the Excel file.
Not on the Excel? Okay.
What? Who are you talking to?
Shut up, Josie.
Oh,
That's Josie.
your sister.
Yes. This is my bed. It's my bunk bed. This is my desk and things. I actually came in here because I need things. Bye, Leila.
Bye. Roommates.
Showing off the awesome dorm.
Yeah.
It's funny. Gosh, dang it. Hey, didn't we? Oh, here we go. Here's what I'm looking for. Okay, do we have the population mean?
Population.
Oh, this was a super easy one. Remember that? Okay. This is where you take the population mean minus the sample mean, and you divide that by the square root of n.
Okay. Population mean.
So does that talk anything about that?
The Excel file doesn't have the population mean or the sample mean.
No. Is it underneath that other file?
Which one?
The What's the other one? Categorical or
Oh, so I'm in the categorical one, but I can look in the, let's see,
quantitative?
quantitative inference.
Sweet.
Oh, 117 t-test for means. Well, that takes a lot of variables.
Do we have all those variables?
I don't feel like we do. Oh, do we? Let me see.
Wait, do we have the mean, standard deviation?
Level of significance is 0.05. That's all we've got.
Okay. Null hypothesis was 6, right? Or
Yeah, 0.6.
six. Type of test. We're doing less than, right?
Yeah.
Okay. What was the mean? Did we have that?
I'm not sure how to find it either. Because
Was the mean 60%?
oh
So
yeah,
0.6.
yeah, 0.6.
Okay. Six. Standard deviation. We don't have that, but what was that formula? No. Okay. I don't know if we have standard deviation.
Yeah. Is there a way to do it? Standard deviation is unknown.
I don't think so. It's in the back of my truck. It's probably really nasty. Okay. Dang it. Yeah, I don't know. You have any idea?
Oh, so we find I think I just figured it out.
Oh, sweet.
So you do the value minus the mean divided by standard deviation. And the standard deviation is just the square root of p minus 1 times 1 minus p divided by n.
Okay.
So p hat minus p. So what's p hat in this case?
P times N would be 0.475 times 80. $38.
Okay, hold on a sec. I'm lost all of a sudden. Okay.
Okay, sweet. Population standard deviation is equal to the square root of the variance. So let me try that. Well, that didn't help at all. Gave me an answer, but says my test score is 0. T-test.
Oh,
I don't know how that works.
yeah, that's interesting.
Did you find something on your?
Yeah, I'm looking into it real quick.
Okay.
So I'm not sure how do we find p.
So P is equal to the P hat, right?
Okay. We'll see, I guess.
Yeah.
Oh.
I think I'm all right with leaving it blank.
Yeah, I'm up to that point too.
I'm at a loss. We submit it. See if we got all of our other ones right.
Okay. You're submitting it?
Yeah.
Okay.
Yep. It's only 1 point, so we're good.
Yeah. Was that the only one we missed?
Yeah.
Awesome.
So I'll take it.
Yeah. I went ahead and I calculated it as with P as the level of significance just to be curious.
Uh-huh.
I don't think it'll do anything, but we'll see.
What'd you get?
Oh, still got it wrong. It
Oh, dang it.
was a long shot, but
Bummer.
oh, yeah, I'll take a 94%.
Exactly.
Won't complain about that.
Nope. Better better than another time, that's sure.
Yeah, we've had some rough ones.
Yep. Oh man. Well, thanks for meeting tonight.
Yeah, thank you.
Sorry. Oh, where'd it go? Sorry it's always been so late.
All good. I did that to you a couple weeks too.
Yeah, it just seems like the only free time in the day during the day.
Yeah.
Or late at night. So cool. Well, was it?
Sounds good. Oh,
Yeah, almost.
um,
Oh, yep.
to submit a project by Saturday.
Oh.
So I read through it today. It's just we got to just like pick like something we can test.
Okay.
Read through it too, but I was just thinking, since there's only the two of us,
Yep.
just something simple like just like testing how many different color of M&Ms there are in the bags. And just
Okay.
I mean Skittles, because people have done it for M&Ms. I've never seen a study for Skittles on it.
Okay.
So,
Maybe we should do something that has a study on it.
I have my for my class.
Not that we cheat, but just so we can double check.
My class.
I see what you're saying.
I should stop the recording. No.
Yeah. Yeah. So I'll let you. Would you like to? We could like video chat tomorrow again and come up with a plan for that.
Yeah, let me read through it tonight.
Yeah.
See what I'm missing.
Tell me what you think. So.
Yeah, that'll work. So.
All right. Sounds good, man.
Sounds good. I'll post this one up. So.
All right.
Okay. Talk to you tomorrow.
All right. We'll see ya.